In this video, I'll demonstrate the three transformations we've looked at, and we'll see how they interact. Here's the environment in which I'll demonstrate transformations. You can see a big yellow rectangle at the bottom of the screen. That's my graphics window. Superimposed on that is a grid. Those grid lines are 100 pixels apart, so each box is 100 pixels by 100 pixels. In the upper left, we have the coordinate system, a big black dot for the origin, a red arrow to the right for the x-axis, and a green arrow pointing down for the y-axis. As in many of the previous videos, those arrows are being drawn 100 times bigger than they really are. The x and y axes are just 1 pixel long, but I'm drawing them at 100 pixels so they're easier to see. I'm also drawing a little picture frame around the origin with colored corners, so we have some sort of a picture to look at to show us what happens as we move the coordinate system around. At the top, I have a bunch of buttons that let me translate, rotate, and scale, so let's go ahead and try it out. First, I'll translate in x by 100 units, and we can see that just moves the coordinate system to the right by 100 units, that's one box, and if I were to draw a picture at this new coordinate system, like the little picture frame, there it is, centered around the coordinate system. If I translate in y, we get the same sort of behavior, and of course we know what's going to happen if I rotate. If I rotate 30 degrees, say clockwise, we rotate around the current origin of the coordinate system. I can also scale. Let's make everything bigger. So I'm going to scale both axes by 1.5. The whole thing gets bigger. I can also scale just in x or just in y. If I scale just in x, it stretches in x. If I scale just in y, we stretch in y. On the right-hand side, you can see a list of all the transformations that I've applied. So if you typed in this list of transformations on the right into your processing program, it would give you exactly the coordinate system we're seeing here. So I'll hit the reset button to set everything back to 0, and let's look at how some of these things interact. So first, let's look at the interaction between translation and rotation. So first I'll translate in x by 100, and then I'll rotate by 30. So we can see that the origin is on the very top of the graphics window, but we're rotated. And this made sense. We moved, and then we rotated. I'm going to reset now, and first I'll rotate, and then I'll translate. And notice that we translated along the direction that the red arrow is pointing in now. And clearly, we have landed in a different place than we did before. So order really matters. If you translate and rotate, you get a completely different result than if you rotate and translate. Let's look at the interaction between translation and scaling. So I'll reset. So first thing I'll do is I'll translate 100 units in x, and then tell you what, to make it really obvious, I'm going to scale in x by 3. So there we are. We're still centered on the top of the graphics window, but now this system is very wide. So I'm going to reverse this. First I'll scale and then I'll translate. So it's reset. So first I'll scale in x, and now I'll translate. So that's different. And what happened was, by translating 100 units in x, we actually moved 300 units in x, because the x-axis itself had grown by a factor of 3. And you can see that at the top of the list, it says scale 3.0, 1. So we scaled x by 3 and y only by 1. So once again, we see order matters. If I translate by 100 units along x first, I move 100 units, and then I scale by 3 and everything gets bigger. If I scale first and then translate, I'm going to move 300 units because my x-axis is bigger. Finally, let's look at the interaction between rotation and scaling. So let's rotate first, and then I'll scale x by 3. So we're centered in the upper left, and the x-axis has been stretched out by 3. Let's reset it, and I'll scale in x by 3, and then rotate. And here you can see some skew. I scaled non-uniformly, and then I rotated. And the box that I'm drawing around the origin, which has previously been a square or a rectangle, is now a sort of tilted over parallelogram. Let's take another look at this. So tell you what, I'll reset things, and now I'll scale in x by 2. And now I'll rotate by 30 degrees. And now I'll scale in y, let's say by 1.5. If I now rotate, say, by minus 20, well, we have the x-axis just about pointing to the right, But you can see, tell you what, I'll translate to the right. You can see that we now have a slanted over coordinate system. Our little picture frame has skewed or sheared to the right. And we got that because we did a non-uniform scale. In one case, I scaled x by 2 and y by 1. In another case, x by 1, y by 1.5, and mixed that up with rotations. When you mix up non-uniform scales and rotations, you get this kind of a shear. So I'll reset everything. And if I scale uniformly, if I scale in x and y by the same amount, and then I rotate, and then I'll scale x and y again. Now maybe I'll rotate 30 degrees positive, and I'll translate. It doesn't matter what I do, I'm not going to get any shear because I'm always scaling in x and y by the same amounts. Let's look at a couple of these using a different picture. Here's my little farm scene, 100 by 100 pixels being drawn below and to the right of the coordinate system. I'll change my translation sizes. I'll make them 300 units so we can really see a big translation. So let's first look at the interaction of translating and rotating. I'll translate first and then rotate. And that's where our farm scene ends up, with one corner at the top of the window and rotate it a little bit. So I'm going to reset, and this time I'll rotate first and then translate. So once again, order matters. And notice that I'll put the translation distance back to 100 so I can move it around. Notice that we always move in the direction of the current coordinate system. So if I now translate in x, we're going to move along the direction of the red arrow. And if I were to make the x arrow bigger, let's say I make it twice as big. So I'm going to scale in x by 2, and now I translate by x. I'm going to move twice as far as I did before because the x-axis is twice as large. All right, let's take a look at shear. I'll reset everything. First, I'll scale in x by 2. Then I'll rotate 30 degrees. Like before, I'll scale in y by 1.5, and then I'll rotate again by minus 20 degrees. And like before, I tell you what, let's translate a little bit in x, and we can see that things are definitely skewed. It's not rotated. The rectangle has become a parallelogram. If I translate in y, I'll move down and to the left. And of course, I can keep playing these games. I can keep scaling up in x, and then I'll rotate in y, let's say by 40 degrees. And now we've got a picture. It's way off screen. There we are. Now it's heavily skewed. And that's pretty cool. Tell you what, let's see if I can find the rotation that'll bring the x-axis pretty close. There we are. So minus 40 degrees. I was just kind of eyeballing it, and it's not exactly right. But this is close to having the x-axis going to the right. And again, we can see that things are skewed. So the 3 lessons to take home are these. First, every transformation builds on the current coordinate system when you call it. If the axes have been made bigger and you translate, you'll move a bigger distance. Second, order matters. The order in which you do the transformations makes all the difference in the world. So if you're doing a bunch of transformations and things end up in the wrong place, grab a piece of paper and a pencil and draw each transformation one after the other. Just a sketch. You don't have to get it numerically right, but just figure out, okay, I'm moving here and I'm scaling and then I'm rotating, and make sure you're doing things in the right sequence. Finally, the third point, as we've seen, scaling non-uniformly, different values in x and y, and mixing that up with rotation will give you skew or shear. If you only scale uniformly, you use the same value for both x and y, you'll never get shear. Let's reset and redraw our picture. Tell you what, I'll translate a couple of times. I'll rotate positive 40 degrees. Translate again, and maybe I'll scale in x a couple of times, and I'll scale everything up again. So the beautiful part of this is you can create your original imagery any way you want, any kind of size, any kind of orientation, and then you can place it exactly the way you want on the screen by preceding it with translate, rotate, and scale commands. Just as another example, I can also draw the bear, and there's the big bear. Tell you what, let's see if I rotate minus 40. Let's see if we can get him to sort of look okay. I'll do it again. Way too much. And there he is, and he's skewed over backwards. Tell you what, let's translate in Y. So he's down there in the yellow zone. And we can see he's leaning backwards. And so if you wanted to make a skewed bear, this is a way to do it. I'll hit reset and I'll just translate and rotate and just do some stuff with the bear here. And you can see I'm certainly not changing the calls to vertex and begin shape that create the bear. That's absolutely fixed. All I'm doing is changing these calls. Whoops, let's move negative 100. All I'm doing is changing the calls that I'm making before I draw the bear. I place the coordinate system where I want at the right size and the right rotation, and then I say draw a bear, and it shows up with respect to the coordinate system. So the key thing to remember about transformations is that as long as you've got your coordinate system in the place and orientation and size that you want, everything you draw after that will be transformed by the current coordinate system.